Alright, so let's find the moment of inertia of the shaded area about the y-axis. So if we follow the strategy I proposed earlier, then if you want the moment of inertia about the y-axis, you would draw a block parallel to that. So this is the differential area that I'm worried we're going to work with first. And it would be dx wide, and it would be y tall. So again, the definition is x squared dA, and dA would be y dx. And what is y as a function of x?
Square root of 1 minus.
Yeah, so it's going to be the square root of 1 minus, what is that?
25.
What did I write? I got confused here for a second. So I'm going to write y, yeah, x over 2, right? That's the way I'll do it.
Oh, yeah.
So the integral that I would like to solve would be x squared times the square root of 1 minus x over 2, and that would be dx. Looks innocent enough, but I'm not quite sure how to do that. I guess you could run the x squared in and get a bunch of stuff, but it gets a little messy. So, maybe that's one kind of scratching my head how to do the integration off the top of my head. So I decided to stop. And I decided to, let's try it again. And let's use our information we know. So let's first, let me sketch the shape of the thing. Now let's do a horizontal block, which we know will be dy thick. Now, in that case, remember our differential is by default what?
Y cubed, x cubed over 3.
Right,
Yeah.
x cubed over 3 dy.
Dy, sorry.
Right? So all we have to do is integrate that. So that's what I'm going to do. I just need to write x as a function of y. What is x as a function of y? It's right there. So I can write, let's see if I can turn this around. It would be y squared, no, it would be 1 minus y squared over 2?
Yep.
Or times 2? Times 2. So that's equal to x. Yeah. And I just need to put that right there. So I'll take my 1/3 out. That's kind of bothering me. So I just have x cubed, which is 1 minus y squared cubed dy. Now, I don't like that much better. That's a lot of work to do, but I think I can do this. I don't know if I can do that one. Oh, I lost my 2. I lost my 2, sorry.
You just pull it out.
My 2 cubed would be 8. Sorry. So let's see if I can do this. So just remember it's 1 minus x squared times 1 minus x times y squared times 1 minus y squared. This should be an integral sign. dy. Oh, let's see if I can do. I don't think I can do all this in my head. I'll do the first term. So this will be 1 minus 2y squared plus y to the 4th. And then I'll multiply it by that. Oh, that'll be fun. Let's see. So 8/3 integral. So let's see. 1 times all that is 1 minus 2y squared plus y to the 4th. And then negative y squared on each one of those. That'd be negative y squared positive 2y to the 4th minus y to the 6th.
We had something like that last night.
Not fun. So 8/3 integral. This should be a little. So I got 1. Looks like minus 3y squared plus 3y to the 4th minus y to the 6th. Okay, so let me slide over here, and that should be equal to 8/3, and now I can finally do the integration. So I've got y minus y cubed plus 3y to the 5th over 3 minus y to the 7th over 7. And fortunately, this is integrated in dy, which is, great, 0 to 1. So I got 1 minus 1 plus 3/5 minus the 7th times 8/3. I don't know what that is. Anybody know what that is? 3/5 minus the 7th times 8/3. I got 1.22. And that would be meters to the 4th. That seems reasonable. So, just to give you some encouragement, this is, for me, that's the problem. If you can get to that point, I wouldn't be that upset if you don't finish it off correctly. I'd definitely give you, 70% of the problem if you got to that point. So if you get to this point on the exam and time is an issue and you say, well, I could do this, but I don't have the time, you could stop. Or I could use the time somewhere else, and I'm pretty sure I could finish the problem, so you can manage your time that way. So the other thing you remember is this definition. So if the first mode or the first approach doesn't work and you have to fall back to this approach, you'll have to commit that to memory. Any questions about that?